Hi, everyone. Thanks for coming out. I'm going to talk today about whether or not high-rate injection is causing the increase in U.S. mid-continent seismicity. And I want to acknowledge my advisor, Shimin Ge, at University of Colorado Boulder, as well as my collaborators, Jonathan Gott, Barbara Beacons, and Justin Rubenstein at the U.S. Geological Survey. So before I can get into answering that first question from the first slide, I want to answer two preliminary questions. The first is the recent increase in U.S. mid-continent seismicity associated with injection wells? And this schematic figure here on the right is a plan view diagram of what we call associated injection wells that are occurring either close to earthquakes and are active at the time of the earthquake, and a vast majority of injection wells that are not associated with seismicity or far away from where earthquakes are occurring. And so the second question we'll ask is, are active injection wells close to earthquakes operationally distinct from those that are not? And this is an important question because the majority of case studies in the past induced seismicity literature just focus on wells inside this circle that are close to earthquakes and don't look at the vast majority of wells that are actually operating without seismicity, or at least seismicity that we can detect. So to achieve these study objectives, we'll first compile an injection well database for the entire central and eastern United States. And we'll delineate injection well populations of associated injection wells and non-associated injection wells based on established spatial and temporal criteria, and I'll get into that in a little bit. Once we delineate these two populations, we can statistically compare the injection parameters of how they're operating: monthly injection rate, cumulative injected volume, injection pressure, and proximity to basement, all of which have been hypothesized to influence whether or not a given injection well is associated with an earthquake. So here's the distribution of injection wells plotted by these small blue circles throughout the central and eastern United States. And what you'll see is that many states have no injection wells whatsoever, and other states have many, many injection wells. This database was built state by state from publicly available sources. And this map shows the distribution of about 95,000 active Class 2 wells currently operating in this area. And this is only about half of the number of wells that have actually operated at one time or another over the past 70 years in this region. And the breakdown of these wells by well type is about 35,000 of these 90,000 wells are saltwater disposal wells, and about 60,000 are enhanced oil recovery wells. So to get a better idea of where these wells really are, and not just plotting these little blue circles, here's an injection well density map. So basically, per square kilometer, the number of wells in that square kilometer, and they really delineate the fields of major oil and gas production. So hot colors here are areas where our wells are closer together. And so the Permian Basin out here in West Texas, as well as the Barnett Shale in Texas, in central Oklahoma and southeastern Kansas, as well as the Illinois Basin, have dense numbers of injection wells. And so I'll talk a little bit about the method. So we use a very, very basic method to delineate whether or not a well is associated. We don't take into account geology or other factors. We're just trying to get a very, very coarse idea of what wells could potentially be associated with earthquakes, as opposed to saying that each well is causally related to that earthquake. And so the spatial criteria is actually the sum of two functions. First is the Davis and Froelich criteria of 5 kilometers around an injection well that suggests it may be associated with that earthquake. And then the other is epicenter location accuracy. We estimate that to be about 10 kilometers, but that's highly spatially variable and time dependent. And the range of our study is from 1973 to March of 2014. So this number is probably larger for vast majorities of that time. The other part of this is temporal criteria. So the well must be active at the time of the earthquake. And we think this is pretty conservative because there are lots of cases of induced seismicity where earthquakes happen well after the shut-in of the operating injection well. So if you take your earthquake database, which is the ANSS catalog over that time period, and the injection well database, and you run this spatial and temporal criteria, what you see here highlighted in yellow are the associated injection wells. And we're being agnostic as to whether or not we think these wells, all of these wells are involved in induced seismicity, but we think that we want to look at how these wells are operating in the region where earthquakes are occurring in the central and eastern United States. And so what we do find is that of the associated well populations, we find many, many more associated wells than have ever been documented before. We find about 15% of the active wells currently in the central and eastern United States are close to earthquakes, okay? And about 70% of those wells, of those active wells, are saltwater disposal wells. So that confirms our intuition that saltwater disposal wells, by the way that they operate with their net positive pore pressure changes, actually are more likely to be associated with an earthquake than enhanced oil recovery wells. Because as we remember, the well breakdown was about 2/3 enhanced oil recovery, 1/3 saltwater disposal. The other portion of this is that associated wells by state. So it turns out that 80% of associated wells are in Texas and Oklahoma. That's not a surprise because Oklahoma and Texas have a lot of injection wells as well as many earthquakes. So if we look at the flip side of the coin and look at the spatially co-located earthquakes through time, from 1973 to 1980, what you see is that there aren't that many co-located earthquakes, but the ones that are co-located, there are actually already 2 cases of induced seismicity in this picture here, the Rangeley oil field out here in Colorado and in Cogdell, Texas, as well as some earthquakes in the Illinois Basin and the Permian Basin. If we move forward to 1990, in the next 10 years, what you see is that there are spatially co-located earthquakes in the Illinois Basin, as well as a lot of other areas in Texas. And the other thing I want to point out is that there are spatially co-located earthquakes in places like near Timpson, Texas, or in southern Alabama, where eventually there will be documented cases of induced seismicity going forward. Moving forward into 2000, we see more seismicity spatially co-located in Indiana and Illinois, as well as some seismicity spatially co-located in Oklahoma. And then finally, the final picture in 2014, central Oklahoma really lights up with a lot of spatially associated seismicity, which most people familiar with induced seismicity know about. But that the important point here is that over this entire period, more than 55% of all central and eastern United States earthquakes are associated, spatially temporally associated with injection wells. And that percentage has risen since 2000 from about 20%. And so this is an ongoing problem. If we look at the same data in histogram form, binning the number of earthquakes associated and all earthquakes in the region by year, what you'll see is that there's about 20% association with injection wells through by year from about 1973 to 2000. But that number actually jumps way up to about almost 200 earthquakes up to March 2014 that are greater than magnitude 3 associated. And so one thing we can say about this data is that the entire increase in recent U.S. mid-continent seismicity is occurring near injection wells or associated with injection wells. And the other portion of this figure is that this black line shows the amount of non-associated seismicity through time, and that essentially has stayed unchanged in the region. Okay? And so if we get back to looking at injection parameters and how these wells are operating that are close to earthquakes as opposed to far away from earthquakes, we can start to try to understand what injection parameters might be really important in determining whether that injection well may be associated with seismicity. And so the following figures I'll show you are injection data from 4 states in the central and eastern United States: Arkansas, Oklahoma, Colorado, and New Mexico. So the first parameter I'll look at is injection rate. And plotted here, I'll go through this figure on the top, is the histogram of injection rates by well of the total well population in blue and of the associated well population in yellow. And the range of maximum injection rates for a given well go from anywhere from about 100 barrels a month all the way up to more than 1 million barrels a month. And the other thing you'll notice is this is not a normally distributed distribution, so we have to take that into account when we're statistically analyzing the data. So if we move down here, if we divide each yellow bar by the blue bar, we get a percent association at a given injection rate. And that's plotted here in the blue line in this bottom figure as a function of injection rate. And what you'll see is that in operating injection wells that are at about 1,000 barrels a month are associated with injection wells, are associated with seismicity at about 35%. But if that same well is operating at over 1 million barrels a month, that well is more than double the likelihood that it's near an earthquake at about 70 to 75%. Okay? And we've estimated some statistical uncertainties here with these 5 and 95% confidence intervals based on the number of wells in each bin. And we think this is a statistically significant trend in injection rate associated with high injection rates associated with seismicity. If we look at the same type of data for each well, but we sum the amount of injected volume over the injection well's history up to the point that the earthquake occurred, what you'll see is that this is also non-normally distributed data, and it ranges from about 10,000 barrels injected to over 100 million barrels injected, several orders of magnitude. We still see this increase in percent association from low cumulative injected volume wells to up to very high cumulative injected volume wells, but we don't see the same statistical significance to the trend, given that there are far fewer wells at these very, very high cumulative injected volumes. So at the scale of the study that we're looking at, we don't think that cumulative injected volume is as an important parameter as maximum injection rate. And I'd also like to highlight the fact that the statistical significance of maximum injection rate seems to cross the threshold of the 95% confidence interval around 300,000 barrels a month. So that may be an injection rate to look for in the Central and East United States. The other portion of this is looking at injection pressure, and similar to other people that have looked at this, looking at the total number of wells at a given injection pressure and the associated wells at a given injection pressure, ranging from about wellhead pressures of 0 psi to more than 3,000, we see no clear trend of increasing injection pressure and the percent likelihood that they're near an earthquake. So this may be a function of the fact that wellhead pressure is improperly reported in some places. It's only one value for an entire month, and we know from well operations that injection pressures vary a lot. We don't know yet how to interpret this data, but at least the way that it's reported currently, injection pressure does not seem to be an important parameter in the likelihood of association. And then finally, proximity to basement. So we take all of the injection depths that we have over actually many, many more states than we have injection volumes and pressures for, and we look at the proximity to basement, or estimate the well's depth to the basement. And we use Mooney and Caban's sediment thickness map that has errors of about plus or minus 15% in the location of the basement thickness. And what you'll notice here, plotted here on the y-axis, is the proximity to basement in meters, and the small yellow bars are the number of associated wells at that given proximity to basement. And we don't see a clear trend of increasing proximity to basement or increasing association when we get to depths that are very close to the basement. But remember, this has been identified in several case studies of induced seismicity, that injection into the basement is a key factor in determining the likelihood of induced seismicity. So this is a large-scale phenomenon that we don't see this being a large factor. So to sum up in a few points, spatiotemporal filtering is an effective first-order tool because it picks up every case of induced seismicity that we know of to date, and as well as many other associated earthquakes. The second point is that the entire increase in recent U.S. mid-continent seismicity is not only the earthquake rate is on the rise, but it's occurring preferentially near injection wells. Injection parameters. High injection rates seem to increase the likelihood of earthquake association. I noted that doubling of likelihood from a very low injection rate up to a high injection rate with association. But it looks like when you compare injection parameters to other areas of the U.S. where there are lots of injection wells, like the Michigan Basin, and no associated seismicity, it doesn't appear that injection parameters play a large role in determining the likelihood of seismicity. So this may be only occurring in places where there's induced seismicity already. And then finally, at the scale of our study, we don't think that cumulative injected volume or injection pressure or proximity to basement statistically significantly affect the likelihood of association. Thanks very much. And I'll acknowledge my funding source, the John Wesley Powell Center for Synthesis and Analysis.
Thank you, Matthew. We have time for one question.
Yeah, your purple dots seem to cover much of the map in that area. I know they're not to scale. Is there much area left through the wells to fit an earthquake that isn't associated?
So the question was, in places like Oklahoma, I'm assuming that the questioner is asking, could you fit an earthquake inside of the pattern of injection wells such that it would not be associated? And that answer is no. But the important point is that we're comparing how those wells are operating spatially and temporally associated with earthquakes to the ones that are not operating that are not spatially and temporally correlated. So we're not saying that all of the seismicity in Oklahoma is induced because it's occurring near injection wells. But what we're saying is we want to delineate the associated population so that we can compare the two. I don't know if that answers your question or not.
Sort of. Could you